February the 15th, 2025. Giuseppe Ferreira, a seismologist monitoring Campi Flegrei's routine tremors, noticed something wrong with the morning data. Instead of random seismic noise, his instruments showed organized pulses, very long period signals with mathematical precision, emanating from exactly 3.6 kilometers below Pozzuoli. Within hours, teams across Europe confirmed his readings. The supervolcano had achieved direct communication between its magma chambers and surface vents. This isn't gradual fracturing, it's systematic engineering. 20 years of pressure have forced Campi Flegrei to construct its own eruption pathway, a fissure network connecting molten reservoirs to steam outlets with mechanical efficiency. The resonance patterns prove the connection is complete, stable, and operating like planetary plumbing designed for maximum pressure release. Scientists describe it as a volcano building its own weapon. They are not explaining why the fracture developed with such precision, why it connects exactly where eruption models predict maximum damage, or how a geological system achieved this level of systematic organization. What happens when a supervolcano becomes its own countdown timer? Why are the pressure readings accelerating faster than any computer model predicted? To understand the severity of Campi Flegrei's fracture network, we need to examine the supervolcano's destructive history. This volcanic complex has been engineering catastrophic eruptions or eruptions for over 40,000 years, reshaping the Mediterranean landscape with systematic precision. The Campanian ignimbrite eruption 40,000 years ago devastated the entire region, spreading ash as far as Russia and leaving a caldera now home to over 1.5 million people. 15,000 years later, the Neapolitan yellow tuff eruption buried land and sea in meters of volcanic deposits, permanently altering the Italian peninsula. In total, scientists have documented over 70 major eruptions in the past 15,000 years, all following mathematically predictable cycles of destruction. But Campi Flegrei's engineering goes beyond size and frequency. Its most recent confirmed eruption in 1538 at Monte Nuovo lasted only a week, but reshaped the Bay of Naples, spawned a 1,300-foot volcanic cone, and ejected more than 816 million cubic feet of material. It was a surgical strike with continental consequences. Today, the data streaming in from seismographs across Europe reveal those systematic patterns are not just continuing, but accelerating. Dr. Giacomo Rapagnani at the University of Pisa said that very long period seismic signals indicate a fracture system connecting the underlying magma reservoir with surface fumaroles. This represents the first documented case of a supervolcano engineering its own eruption infrastructure. The precision is staggering. Geophysicists have isolated 4 distinct episodes of crustal rupturing beneath Campi Flegrei, from 1950 to 1952, from 1969 to 1972, from 1982 to 1984, and the current sequence that began in 2005. Each cycle shows progressive weakening of the crust, inching the fractures closer to the surface. In 2016, scientists predicted the network would fully connect after an additional 30 to 40 centimeters of ground deformation. Campi Flegrei overperformed that estimate by 400%. Current ground uplift has surpassed 1.4 meters, forcing the fractures to not just meet but merge into a superhighway between magma and open air. The supervolcano hasn't just exceeded human models, it is operating on a timescale beyond human imagination. Advanced seismic imaging from the GFZ Helmholtz Center reveals exactly how Campi Flegrei constructed this underground magma highway. The fracture network descends over 3.6 kilometers, forming a direct conduit between active magma reservoirs and the surface. But this is not a random series of cracks. The fissure geometry shows systematic organization optimized for rapid magma ascent. Resonance frequencies across the network remain eerily constant. This proves these are not temporary weaknesses, but permanent pipelines carved into the crust. Even more alarming are the feedback loops now pulsing beneath Naples. As magma pressure forces each fracture wider, it creates more space for molten rock to fill. That additional mass then pushes against the crust with even greater force, accelerating the next rupture in a cycle of self-amplifying pressure. It is a doomsday mechanism that begins slowly, but builds momentum with mathematical certainty. The seismic data confirms the devastating efficiency of this system. In the past 3 years alone, 18,500 earthquakes have shaken Campi Flegrei as the fractures rip themselves open. Seismic swarms now burst to life with increasing frequency, staccato beats of geological violence, separated by shorter and shorter moments of eerie silence. Above ground, massive carbon dioxide emissions, reaching 1,557 tons per day, pour from volcanic vents and soil degassing, matching the discharge of fully active volcanic systems. The fractures have transformed Campi Flegrei from a geologic hazard to a coiled spring compressed to its limit, positioned for maximum destruction. The latest data gives no signs of stabilizing. The ground continues rising over 2 centimeters per month with no sign of slowing down. Earthquake frequency has exploded exponentially, generating over 1,000 seismic events per month. Magnitude 4.4 and 4.6 earthquakes in 2024 set records as the most powerful in Campi Flegrei's modern history, sending shockwaves through the crust and citizenry as evacuations rattled Naples. Meanwhile, those very long period signals first detected by Giuseppe Ferreira continue pulsing through the completed fracture network. The supervolcano has created an underground monster, one that grows stronger by the day as it whispers to itself through kilometers of solid rock. The immediate human impact of Campi Flegrei's fracture zone is difficult to overstate. Over 900,000 people now live directly above these magma highways, with population centres like Pozzuoli and Bagnoli sitting on top of the most heavily fractured crust. Shaking from the magnitude 4.4 and 4.6 earthquakes in 2024 generated ground acceleration up to 1 g in nearby towns. That is the equivalent of objects briefly floating off the ground as seismic waves rolled through. Even more concerning, the highest accelerations occurred near elementary schools, apartment complexes, and critical infrastructure like the Pozzuoli port, all sitting above the supervolcano's pressure release valves. But Campi Flegrei's magma network won't just devastate Naples. Geophysicists have detected correlation patterns between ground uplift at Campi Flegrei and sinking at Mount Vesuvius, just 10 kilometers away. This suggests underground connections are allowing magma to circulate between the two volcanic systems, using the fractures as a subsurface superhighway. This magma transfer could destabilize the entire Campanian region, reawakening nearby volcanoes and triggering devastating earthquakes like the Irpinia earthquake in 1980. This process raises the risk of widespread reawakening. Even the International Association of Volcanology and Chemistry of the Earth's interior has added Campi Flegrei to its list of decade volcanoes, citing the threat of large volcanic eruptions near densely populated regions, with potentially catastrophic impacts on economies and transportation networks at national and global scales. But the true danger of Campi Flegrei's fracture network is how dramatically it rewrites the rules of eruption timelines. This is the first time in history that a supervolcano has constructed a full-fledged magma transport system, bypassing the gradual and random pathways typical of geologic processes. It is a feat of systematic engineering that compresses eruption timelines from centuries to decades. The fracture network now reaches depths beyond all human infrastructure combined, creating planetary risks we have no frame of reference to calculate. Campi Flegrei isn't just threatening Naples or even Italy, it is rewriting the geologic order of the Mediterranean. In December 2024, Dr. Simone Cheska of GFZ Potsdam issued an urgent warning. The resonance frequency has not changed over the past few years, indicating that the overlying rock above the magmatic reservoir is currently stable. But as any engineer knows, stability in an unstable system is never a sign of safety. It is proof the system is working exactly as intended. Traditional eruption warning signs no longer apply to Campi Flegrei. Sudden steam-driven explosions could devastate historic towns, with little to no warning as pressurized fluids shoot through the crust at supersonic speeds. These events would be sudden and catastrophic. Evacuation plans designed for gradual magma ascent would have minutes, not months, to clear over 900,000 people from the blast radius. This is what happens when a supervolcano evolves from a geologic hazard to a systematic threat. It is no longer a question of if or even when Campi Flegrei will erupt. The magma transport network will erupt because that is what it was designed to do. The only question is what will trigger a system built for maximum destruction. Will it be a steam explosion as the fractures split open near waterlogged soil? A sudden depressurization as magma forces its way to the surface? Or the cumulative stress of 18,500 earthquakes in 3 years rippling through a volcanic complex already primed to erupt? Campi Flegrei spent 20 years building its magma weapon. Now, it is just waiting for the firing pin to drop. And with seismographs clocking pressures rising faster than scientists can model, the countdown may have already begun. Because when a supervolcano designs its own eruption trigger, it is not a matter of watching and waiting. It is a question of how quickly we can realize that the system we are monitoring is no longer the one in control. Campi Flegrei's fracture network is not just a geologic threat. It is a civilization-level challenge to our assumptions of a stable planet. So the next time a news alert tells you not to worry about the earthquakes rumbling beneath Naples, the evacuation sirens echoing through Pozzuoli, or the steam vents suddenly whistling with high-pitched fury, take a moment to consider the question that 900,000 Italians may soon be forced to ask. What do you do when the ground beneath your feet has been carved into a magma superhighway aimed directly at your front door, and the supervolcano that built it is nowhere to be found? This is Earth Attacks, where we reveal the systematic threats reshaping our planet, while institutions remain silent. Subscribe now so you are on the front line of information before disaster strikes.